uh, 2212 Lab 1 um, charge tapes. And in this experiment, we analyze the behavior of charges between clear tape, between our hand and the tape's interaction with each other. So our procedure is we create a base tape and a U tape, and we stick the U tape onto the base tape and quickly pull it off to create an electrical field, which will incur an electrical charge. Then we record the interactions between these two tapes. We determine the charge um, with of the tape with a regular pen. Then we want to estimate the excess charge by floating a U tape above another and balancing the different gravitational and electrical forces between them. We use this to calculate the charge via calculating the excess electrons and the ratio of excess electrons to the total number of atoms, which will allow us to compute the final charge. So here are some of the values in our experiment. We have a length of the tape being about 31 centimeters. Using the assumption that clear tape is a gram a meter, we can say that the mass of one of the pieces of tape is 3.1 times 10 to the negative 4 kilograms. Here's our computed distance between the two tapes when they float with each other, and simply using the physics 1 concept, Newton's second law of motion, the force of gravity, the magnitude of the force of gravity is just the mass of the tape multiplied by the gravitational constant. We also can say that the magnitude of the electrical force is equal to the magnitude of the gravitational force because of the balancing force that occurs due to the lack of motion. By using the excess number of atoms, our measured electric charge through our experiment was 2.43 times 10 to the negative 8 coulombs. Okay, so moving on to the coding portion of the lab, we used a rearranging of Coulomb's law to solve for the net charge. Essentially, we use Fg instead of Fe here because if you remember earlier, our balancing force allows these two forces to be the same. And computing this, we got Q to be 3.13 times 10 to the negative 8 coulombs. So assuming the charge in one piece of tape is a model with a line of charges, we got a reasonable Q value, coulombs, but I'm not exactly sure how this diagram came up, but I guess it kind of worked out with the reasonable Coulomb value of 4.37 times 10 to the negative 7 coulombs. And this means that our model that shows the tape as a line of charges has a higher charge than the assuming the tape's a point charge. So in our first model, we assume that the tape is a point charge, which is probably like the biggest assumption of that. We also assume that we approximate the weight or the mass of the tape to be 1 gram per meter, and we also assume that there's no air resistance. So if the signs of the electrons and protons were reversed, nothing would really change with the observations because given Coulomb's law, the signs would simply reverse and stay consistent throughout the analysis of our experiment. So the reason why the line charge model is going to be more accurate than the point charge model is because the charge density throughout the or the charge density is modeled throughout the tape with the line charge model, And with the point charge model, we assume that the density is concentrated in one point. So the distribution of charges are modeled through the line charge model, which will allow it to be more accurate. And yeah, that's about it. Thank you.